This is the first assignment for Quiz 5. Make sure you print off the reference material here as usual. And there's a little workspace template sheets that will help you to do this with the quadratic formula. So we are now going to embark upon finding x-intercepts. Instead of completing the square, we are going to be using the quadratic formula. And it's that hefty dude. So what I teach is to take the b squared minus 4ac, which is called the discriminant, and let's figure that number out right away, because we're going to have to reduce that square root, which is enough work in and of itself. And then, of course, if it's negative, we got to take out an I. And then we need to reduce the quadratic expression like we did on the one assignment in the last quiz at the end. So I will do a few of these out. You might want to number this first to correspond to the problems in your workspace. So we have 20 of them, so I will go up to 20. Just number it out, and that way you're not writing the wrong problem in the wrong space, and neither am I. And pretty much this unit is dedicated to the quadratic formula and analyzing that number that we're going to calculate right away, called the discriminant, to help us determine, if something's going to factor real easy. Because always remember that, there's my little advertisement again, that the x-intercepts are always related to the factoring. Okay, we need them to do a factoring that's going to be 100% accurate, and that's what your page of notes is getting at, about the type of value the discriminant is, and then how that's related to factoring, so on and so forth. Okay, so number one will be the first one that we do. And so 2n squared plus 3n minus 6. So a is 2, b is 3, c is negative 6. That's the very first thing that you have to get down. And I'm going to tell you that it might be good a couple of times to start with what's called the shell. There's the shell, and we're going to figure out the b squared minus 4ac. And that value is 57. And I need to show you something on the calculator that you need to be very careful when that's the majority of the work on this, is doing the b squared minus 4 times a times c, and give everything a set of parentheses that you're subbing in for. To do that carefully, and then that's the number that's going to be under that square root. And then you just simply fill in with the rest. So b is 3, and then a is 2. So you might want to write down off on the side here so that you can see them and that you don't mess it up. So that's what we're trying to reduce. And we're trying to, first of all, look at the square root of 57. Does that reduce? And basically, its only divisors are 3 and 19. So that's not going to reduce. You have that page, which I'm not going to bring out. So this is done. So 57 doesn't reduce. When the square root does not reduce, you are done. So I'll try to do enough of these where you'll see how it works. Now, these represent the two x-intercepts on this quadratic, and it represents the case of, and you have the better page of notes to look at the type of graphs, but it represents two real roots, irrational roots. There would not be any factoring on this, so most of these are, if I said factor this quadratic, this would not be factorable. because it didn't produce nice x-intercepts. These are just long decimals that will not convert to an integer or a fraction. Remember, we need integers and fractions to factor. So if I said factor this, your answer is prime. And that's actually what's going to happen on actually on all of these, because they're all irrationals. So you have to try to keep the big picture in mind as you go to do these problems. So number 4, we have A is 2, and B is 4, and C is -4. And then we get our b squared minus 4ac to be 48. So anytime we calculate this number here that goes under the square root, and it's not a perfect square, a number that we can take the square root of nicely, there's no factoring. It's prime. Or if it's negative, there's no factoring. That has to be something we can take the square root of easily, where we get a nice whole number answer. Okay, plus and minus the square root of 48 all over 2 times 2. So there'd be a little second step here. So the square root of 48 will break down as the square root of 16 times the square root of 3. You can look up 4 times the square root of 3 if you want. So most of these are going to have this second step because the square root will reduce. And then, so 4 will divide into all of those, making this for our final answer. Again, if I said factor this, your answer is prime, because you cannot have irrational or imaginaries, which we're going to get to in the next assignment, answers in factor. So number 7, we have A is 2, B is 0, and C is -7. So make sure that you're understanding I'm referring to this. This is what you need to be looking at. So I'm just writing the A, B, and C values down. Then start with the template. And then a b squared minus 4ac value. This time it's 56. Okay, so that's going to go in, and then b is 0, and over 2 times 2. So 56, 9 and 6. So plus and minus 3 times the square root of 6 over 4. All right, so let me correct myself. It's the square root of 4 times square root of 14. I was thinking of 54 when I did that. And then reduce. So always check your work. This is pretty simple to make mistakes on. So the 2 and the 4 reduce. There's a 0 out here, so you don't even write that in. The 2 and the 4 reduce, so we have square root of 14 over 2. Kind of an awkward result, but that is what you get. And then I would like to just skip to number 20 and jump ahead to the end a little bit here. So we have 3 and 5 and -10. And so our b squared minus 4ac is 145. And that will not reduce, so this is why I'm doing this one, just so you don't spend a whole lot of time. If you had to reduce, I know that you could literally type that into a search engine bar, square root of 145, and somewhere it would pull up a square root reducer. So 145 is what goes underneath here, and then A is 3 and B is 5. So since that does not simplify, we are good. You go right to the final result. So big picture again, what is it we're doing? we're finding the exact solutions instead of writing the big decimals out to these quadratic functions. So if I went in, just to relate this a little bit, and then I'll be done, I went into my poly root binder and I put in 3, 5, and 10, like so, -10, meant to say. Those two values right there are what you get when you do this. So if I was to go out to my main screen, remembering -2.8, I'll just do one of these, minus the square root of 145, over 6. So it's doing that value. And then if I just went and changed the sign, it would give me the other one. So it's just the exact values of the roots. That's all that's going in.